In this video, we're going to talk about how we can solve some radical inequalities. So to solve a radical inequality, we want to make sure, first of all, that it's in a form that we're familiar with or that looks like a radical inequality. So it looks something like the nth root of x is less than d. Now this less than could be greater than or less than or equal to or greater than or equal to, but we need to make sure that x is an algebraic expression and d is a non-negative number. Okay. So we're going to raise each side to the exponent n to basically undo the index that we're taking, or the square root of the cube root. And like we said a minute ago, this also works for our other three inequality symbols. Now, one thing we want to make sure of is that we consider the possible values of the radicand. And what we mean by that is what's under the radical, that's our radicand. Remember when we're talking about graphing radical functions, the domain has to be greater than or equal to 0. Okay, so we're always going to make sure we add that in, especially if we're using a less than or equal to symbol. So let's jump in. We're going to do 4 examples here. We're going to do, these first 2 examples have a less than or equal to sign. Number 3 is just a less than sign, and number 4 is a greater than or equal to. So for number 1, we're going to go ahead and add 4 to isolate. So we have 3 times the square root of x is less than or equal to 12. Now let's divide both sides by 3. So we get the square root of x is less than or equal to 4. And now we can square both sides. So far, just like solving a radical equation. So we get x is less than or equal to 16. Now, since it's less than, we want to make sure that we consider the values of our radicand. So our radicand, we had what's under the radical. Remember, that has to be greater than or equal to 0. So essentially, we have these 2 inequalities, and we want to write them together as a compound inequality. So we would just write this as x has to be, x has to be less than or equal to 16. And we have 0 over here, and x, I think I wrote my symbol wrong here. This needs to be greater than or equal, okay? So we have an and compound inequality representing the possible solutions of x. Okay, it has to be between 0 and 16. We could include 0 and 16. All right, number 2. We can go ahead and divide both sides by 3. So now we have the square root of x minus 1 is less than or equal to 4. Go ahead and square both sides to get rid of your radical. So now we have x minus 1 is less than or equal to 16. Now we can add this 1 and we get x is less than or equal to 17. But once again, consider the possible values of your radicand. X minus 1 has to be greater than or equal to 0. So we add 1 and we know x has to be greater than or equal to 1. So once again, let's put these 2 radical expressions together, or radical inequalities together as one compound inequality. So we would say that 1 has to be less than or equal to x, and x has to be less than or equal to 17. So our values for x could be greater than or equal to 1 and less than or equal to 17. Okay, now for number 3, we have 4 times the square root of x plus 3 is less than 10. So let's subtract this 3 here. So we have 4 times the square root of x is less than 7. And now let's divide by 4. So now we have the square root of x is equal to, and I'm just going to, not equal to, is less than. I'm just going to leave this as 7 over 4. Why? Because to undo my radical, I'm going to square this. And so let's just say x is less than, and this would be 49 over 16. Okay? Now, this is part of our radical, or excuse me, part of our inequality. But once again, consider the possible values of your radicand. X has to be greater than or equal to 0. So let's put these 2 inequalities together. And let's say that 0 is less than or equal to x, but x is less than 49 over 16. So possible values for x have to be greater than or equal to 0 and less than 49/16. Okay, last example, we have a greater than or equal to sign. So it's going to change it up just a little bit, but not a ton. So let's add 6 to both sides. So we have 2 times the cube root of x is greater than or equal to 16. And let's divide both sides by 2. So we get the cube root of x is greater than or equal to 8. And now let's cube both sides. So we get x is greater than or equal to 512. Now, consider the possible values, but do we have to consider the possible values? No, because we're talking about a cube root instead of a square root, okay? So we're just gonna say x is greater than or equal to 512. Now, let's say this were square root. So let's say it was like this, 2 times the square root of x minus 6 is greater than or equal to 10. So we do the same thing, we add 6, we divide by 2, we're going to end up with square root of x is greater than or equal to 8. So now we square both sides, we get x is greater than or equal to 64. okay? Now, we consider the possible values of our domain because it's a square root function. So we would say x has to be greater than or equal to 0. Well, is 6, we already have one expression or one equation, one inequality that says x has to be greater than or equal to 64. So if x is greater than or equal to 64, isn't it already greater than or equal to 0? Yes, right? So we could just say this would be our one inequality that we would have to write in that case, okay? And that is how you can solve some radical inequalities.